In 1859, a doctor examining a stillborn infant found something that shouldn't have been there: a small functioning muscle in the exact spot where a tail would grow on almost every other mammal on Earth. It wasn't a birth defect, it was a memory. Reach up right now and touch the very base of your spine, right where it curves inward. That small triangular bone you're feeling is called the coccyx. It's made of 3 to 5 tiny vertebrae fused together, and for most of your life, you probably never think about it at all. But 6 weeks into your development, before you were anything close to recognizable as human, you had a tail. Every single human embryo grows one. It's not a metaphor, it's an actual physical tail, complete with 10 to 12 vertebrae extending out past the rest of the developing body. So what happened to it? Around week 8, something remarkable occurs. Specialized cells trigger a process called apoptosis, essentially programmed cell death, and the tail is reabsorbed back into the body. The vertebrae fuse. The tissue disappears. By the time you're born, all that remains is that small triangular bone at the base of your spine, and almost nobody ever asks why it was there to begin with. Charles Darwin was one of the first people to take this seriously. In 1871, in a book called The Descent of Man, he pointed directly at the coccyx as evidence that humans share ancestry with tailed animals. He wasn't guessing. He'd studied embryology closely enough to know that a structure this specific, appearing this consistently in every single human embryo, doesn't show up by accident. Evolution doesn't waste effort. It doesn't build something elaborate just to delete it for no reason. If every human grows a tail and then loses it, that's not a design flaw. That's a leftover instruction. Still running, after millions of years, from ancestors who actually needed one, and they did need one. Go back roughly 25 million years to the common ancestor shared by humans and the other great apes. That ancestor had a tail, the same as most other primates today. Tails aren't decorative in the animal kingdom. They're used for balance while moving through trees, for communication, for swatting insects, and in some species, for literally grabbing branches like a fifth limb. Somewhere around 20 to 25 million years ago, something changed. A single gene shifted course, and an entire body plan followed it. A mutation occurred in a gene called TBXT, sometimes called the tail gene, and it began switching off the biological program that built a functional tail in adulthood. This wasn't one dramatic event. It was slow genetic drift, and it happened specifically in the ancestral line that led to apes, humans included. Monkeys kept their tails. Apes didn't. Why would evolution remove something that useful? The leading theory has to do with how our ancestors started moving. As primates transitioned from swinging and balancing in trees to a more upright posture, first knuckle walking and eventually walking fully upright, the tail's original purpose, balance during arboreal movement, mattered less and less. A body that no longer needs a counterweight doesn't keep building one. Evolution isn't sentimental. If a trait stops paying for itself, it gets phased out. Not immediately. Mutation by mutation, generation by generation, over enormous stretches of time. But here's where this gets stranger. Because the coccyx isn't just a leftover bone doing nothing. And here's the part almost nobody talks about. It still works. The coccyx anchors 9 separate muscles, 3 ligaments, and it plays an active role in something you rely on every single day: sitting down. When you sit, especially leaning back, your coccyx actually shifts position slightly, moving forward to help distribute your body weight across your pelvis. It also supports part of your pelvic floor, which affects bladder control, and it acts as an attachment point for muscles involved in bowel movements. In 2003, French researchers using dynamic-MRI scans confirmed that the coccyx moves in a measurable functional range during posture changes, something doctors had assumed for decades but hadn't directly observed until imaging technology caught up. Remove it entirely, which surgeons occasionally have to do in extreme medical cases, and patients report real, lasting difficulty with both continence and stability while seated. The tail is gone. The job it used to do partly still exists, quietly reassigned to the small fragment left behind. And sometimes, the tail doesn't fully disappear at all. Roughly 1 in every 100,000 human births involves what's clinically documented as a vestigial human tail, not a birth defect caused by a mutation gone wrong, but the opposite, a case where the normal process of apoptosis, that programmed reabsorption during week 8 simply doesn't complete properly. The result is a small, sometimes several-inch long, boneless, soft tissue tail extending from the coccyx. Medical literature going back over a century documents dozens of confirmed cases. Some contain muscle tissue. Some have even shown limited voluntary movement. In several documented cases, published in peer-reviewed surgical journals, these tails were successfully removed with no lasting complications, precisely because they were never load-bearing structures to begin with, just an ancient developmental program that ran slightly longer than it was supposed to. For most of the 20th century, doctors assumed anything found in this category was simply a random tumor or growth. It wasn't until genetic and embryological research matured that the medical field widely accepted these as true vestigial tails, direct, physical evidence of a program still sitting dormant in your DNA, occasionally misfiring and running to completion instead of stopping halfway. Your body is still carrying the blueprint. It just usually knows to stop building before the tail finishes forming. And the tail isn't the only leftover instruction still sitting inside you. In the corner of your eye, closest to your nose, there's a small pink fold of tissue called the plica semilunaris. In most animals with a nictitating membrane, a functional third eyelid used to protect and moisten the eye without fully closing it, that structure is large, mobile, and actively used. In humans, it's shrunk down to a tiny immobile fold that does essentially nothing. It's the exact same structure, just switched off, the same way the tail was switched off, just further along in the process of disappearing entirely. Your forearm carries one too. Make a fist and bend your wrist slightly forward, and roughly 85% of people will see a thin tendon pop up in the middle of the wrist. That's the palmaris longus, a muscle that, in most primates, is critical for gripping and climbing. In humans, it does almost nothing measurable, and about 1 in 7 people are simply born without it entirely, with zero effect on grip strength or hand function. Surgeons routinely harvest it for use in reconstructive procedures elsewhere in the body, specifically because losing it changes nothing. Each of these, the coccyx, the third eyelid, the wrist tendon, tells the exact same story from a different part of the body. None of them are mistakes. They're historical records, written directly into your anatomy, of jobs your body used to do and slowly stopped needing. Evolution rarely deletes a structure instantly and completely. It shrinks it, reassigns it, or leaves it dormant, half-built, ready to occasionally reappear when the switch that's supposed to turn it off doesn't quite finish the job. You were, for about 2 weeks of your existence, a slightly different animal than the one you eventually became. Your body built it carefully, vertebra by vertebra, following instructions passed down from ancestors who used it every single day of their lives. And then, before you were even the size of a grape, your own body quietly took it apart again, kept the part that still had a job to do, and moved on. Somewhere in you, that program is still there, waiting for a set of instructions that, for the vast majority of human beings, will simply never be needed again.